Section 1.6, inverse functions. We're talking about functions that are inverses of one another. What happens is our domain and range switch positions within our function. If f composed with g of x and g composed with f of x both equal x, then we know that f and g are inverses of each other. The inverse of f is denoted in that notation. That does not mean f raised to the negative first power. That is simply read as f inverse. So don't get confused and think of that in the traditional sense of an exponent. It's just a notation for denoting the inverse of the function. Inverse functions are always symmetric to each other about the line y equals x. Remember what our line y equals x looks like. Y equals x splits quadrants 1 and 3 diagonally. So if we're dealing with two functions that are inverses of each other, if I take and graph both of those functions, and I fold the coordinate plane diagonally over that line y equals x, both halves of our graphs should match up if the two functions are indeed inverses of one another. To verify that two functions are inverses is what's highlighted right here in yellow. We have to show that the composition in both directions is equal to x. Show that f of x equaling x plus 2 and g of x equals x minus 2 are inverse functions of one another. So what we need to do here is take the composition in both directions. We need to find f of g of x, which is going to be f of x minus 2. So now in my f function, I'm going to put in x minus 2, where I had x. Simplify, and we see that that's just equal to x. Do the same thing going the other direction. Find g of f of x. That's g of x plus 2. Plug in x plus 2. Simplify, and we get x. Showing that the composition in both directions equals x is how you verify that two functions are indeed inverses of one another. Show that y equals x cubed and y equals the cube root of x are inverse functions. Notice this isn't written in function notation here, so I'm going to say that this one I'm going to call f of x. This one I'm going to call g of x, so that when we use our notation, we know which one we are referring to. So I need to find f of g of x first. That's f of the cube root of x. So now in my f function, I need to put in the cube root of x where I had x, and when we cube a cube root, undoes each other, they are inverses. We're just left with x. Do the same thing going the other direction. Find g of f of x. That's g of x cubed. So now in my g function, where I had x, I'm going to put in x cubed. When we take the cube root of something cubed, they cancel. And again, we're just left with x. We've shown the composition in both directions is x. Therefore, we know that they are inverses of one another. Find the inverse of each function, then verify that they are inverses. Okay? Well, we know to verify that we're going to have to show the composition in both directions equals x. To find an inverse function, we have to go back to what we talked about on the first slide. Remember on the first slide, we said the domain and range switch positions. Domain typically talks about what kind of values? X values. Range talks about Y values. So to identify the inverse of a function, if the domain and range switch, all we are going to do is switch X and Y. If I switch X and Y here, we get X equals the cubed root of Y minus 5. And now we need to resolve that equation for Y. Begin solving for y. I need to get rid of that cube root. The opposite of taking the cube root of something is to cube it. So I cube both sides, leaving me with that. Add the 5 over. Y is equal to x cubed plus 5. So that is our inverse function. So f inverse of x is equal to x cubed plus 5. That's how you identify an inverse function. Simply switch x and y, resolve the equation for y. That will be your inverse. Now we also need to verify that these are indeed inverses, so let's go ahead and do that. To do that, we need to find two things. We need to find f of f inverse of x, so let's do that first. F of f inverse. Well, f inverse is x cubed plus 5. So now in my f function, where I had x, I need to put in x cubed plus 5. Simplify. Underneath the radical, we get x cubed plus 5 minus 5. 5's cancel. Cube root of x cubed is just x. So we've shown it's true in one direction. Now I need to find f inverse of f of x. That's f inverse of, what's f of x equal to? The cube root of x minus 5. So now in my inverse function, where I had x, I'm going to put in the cube root of x minus 5. Simplify that. When we cube a cube root, we get what's underneath. 5's cancel, and we are just left with x. Same thing, find the inverse, then verify that they are indeed inverses. Let's find the inverse first. To find the inverse, we switch x and y. So I'm going to get x equals y minus 4 over y plus 2. We need to solve this equation for y. Let's multiply the y plus 2 over to the other side. Distribute xy plus 2x equals y minus 4. We're trying to solve this equation for y. Think in the most general, basic terms. What do you do when you're trying to solve an equation for a variable? You want to get everything that has that variable on one side, everything that doesn't have that variable over to the other side. So I'm going to move the y's all over to the right, everything else to the left. So I'm going to add the 4 over, and I'm going to subtract the xy. We're trying to solve for y, so we need to get a y out of this right side. I can factor it out, and now divide by what's left. We get y equals 2x plus 4 over 1 minus x. So that means our inverse function, g inverse of x, is equal to 2x plus 4 over 1 minus x. There's our inverse. Now we need to verify that this indeed is the inverse of that. We do that by taking the composition in both directions. And algebraically, this is going to be a lot of work. Okay, so I'm going to verify one of them on this slide. I'm going to verify the other direction on the next slide. Again, a lot of algebraic work here, but you're going to have to be able to do this on the test, so make sure that you're able to do it here. We need to first find g of g inverse of x. So that's g of 2x plus 4 over 1 minus x. So now in our function g, where I had x, I need to plug in that entire expression. So I have 2x plus 4 over 1 minus x. Minus 4, there's our numerator. Our denominator then is going to be 2x plus 4 over 1 minus x plus 2. Now we have a complex fraction. Remember, we've talked in here since the beginning of the year that you have to know how to simplify complex fractions. There are 3 steps involved every time. I'm going to look only at the numerator stuff first. So I'm going to look at all of this. And I want to get a common denominator in the top and simplify that as much as possible. So let's go ahead and do that first. Our common denominator is going to be 1 minus x. So I have 2x plus 4 minus 4 times 1 minus x. Next, I want to look at just the bottom portion right here. Do the same thing. Get a common denominator and simplify as much as possible. Our common denominator again is going to be 1 minus x. So I have 2x plus 4 plus 2 times 1 minus x. Now begin simplifying that. If I come over here and I look at the top, I get 2x plus 4 minus 4. So the 4's are going to cancel. I'm left with 2x plus 4x, which is 6x over 1 minus x. In the bottom, we get 2x plus 4 plus 2 minus x. Or I'm sorry, minus 2x. The 2x minus 2x is going to cancel. 4 plus 2 gives me 6 over 1 minus x. And now your third and final step, every time you have a complex fraction, multiply up by the reciprocal. When I do that, the 1 minus x's cancel. I'm left with 6x over 6, which is just x. So there's the verification one direction. We now need to go to the other direction. Let's go to the next slide to verify that. So now this time we are finding G inverse of G of x. That is G inverse of G of x was equal to x minus 4 over x plus 2. So now in the inverse function, where I have x, I need to plug in that entire expression. So we get 2 times x minus 4 over x plus 2 plus 4. There's my numerator. In the denominator, we get 1 minus x minus 4 over x plus 2. Complex fraction, do the same 3 steps. Look only at the top portion first. So I'm looking only at the numerator. I need to get a common denominator up there and simplify. Common denominator is going to be x plus 2. We have 2x minus 8 plus 4 times x plus 2. Do the same thing now on the bottom. So I'm looking only at this bottom part. Get a common denominator. What's it going to be? X plus 2. So we get x plus 2. Distribute that negative through, minus x plus 4. Simplify. Up top, we get 2x plus 4x is 6x. Negative 8 plus 8 is gone, so I'm just have 6x over x plus 2 in the top. In the bottom, x is canceled. 2 plus 4 is 6 over x plus 2. Again, multiply up by the reciprocal, and once again, we're left with 6x over 6, which is just x.